Hello, in this our Shiny App Universal Dashboard. First, we will load all the libraries needed for this dashboard. Shiny and Shiny Dashboard build the web app and dashboard layout. Multiplier helps with the data manipulation. ggplot is used to draw all the charts. dt creates interactive data tables. Duplicate help work with the dates. Forecast and tsf cannon are used for time series forecasting models. In the step 2, build the dashboard layout. Next, the user interface is defined using dashboard page. The header shows the title Universal Analytics Dashboard. The sidebar contains the navigation menu with items overview, data transform, analysis 1, analysis 2, forecasting, insights and reports, video overview and contact. The body contains one tab for each of these pages where all the blocks, plots and tables are placed. Next we have the overview page. On the overview page, at the top, three value boxes show the number of rows, the number of columns, and the total missing values in the plotted data. There is a file upload box where the user selects a CSV file and sets header, separator, and code options. There are boxes showing the shape of the data, the type of each variable, a high level summary of the entire dataset. At the bottom, a page guide explains what each page in the dashboard is used for. Next, we have the core data logic in the server. In the server function, the data flow is set up. A reactive called our raw data reads a uploaded CSV file using the options the user choice. A reactive values object RV stores the current working dataset. When a new file is uploaded, an observer updates the RV data. Another reactive current data always returns the latest version of the dataset. All the other pages in the app uses current data, so when the data changes, every tab updates automatically. In the step 5, we have the data transform page. On the transform tab, there is a drop down to select a column to new. When the new selected column button is selected, that column is removed from RV data. There is a section to create a new numeric column. You can choose numeric column X and numeric column Y. You can choose an operation to perform on these new columns. To create these new columns as some difference product or ratio, you type a name for the new column. When you click to create the new column, the app calculates the result, handles division by zero safely, and adds a new column into the dataset. On the right side, the data transformed dataset is displayed as an interactive table. Below, there are descriptive statistics such as it includes the mean, median, standard deviation, minimum and maximum values for a selected numerical variable. A table showing how many missing values each column has. In the step 6, the analysis page 1, the first section on the analysis page 1 is the scatter plot. The user selects an x numeric variable and y numeric variable and an optional grouping variable. A checkbox to add or remove a linear trend line. This code uses three inputs to draw a scatter plot optionally colored by group and can add a single straight trend line using a linear model. The second row has a box plot that shows how a numeric variable is distributed across the levels of the grouping variable. A density plot that shows the distribution of a selected numerical variable as a smooth curve. The last row creates a correlation heat map. This app selects only a numeric columns, calculates their correlation matrix, converts it into a log format, and plots it as colored tiles. The colors shows how strong and in which direction the correlations are. Next, we have the analysis page 2, distribution and trends. On analysis 2, the first row has a Boolean plot. The user selects a numeric variable for y and a grouping variable of x. The Boolean plot shows the full distribution of the numeric variable for each group. The second row includes a histogram where you can choose a numeric variable, optionally a grouping variable, and the number of pins. The histogram shows the frequency distribution, a numeric versus numeric trend plot. You choose numeric x and y variable and can add a smooth line to show the trend between them. Next, at the third last, we have the page of forecasting. On the forecast tab, the user selects a time or index variable, a numeric variable, a forecasting model, name, ETS, or Canon, a model horizon, which is how many future points to predict. This app then prepares time series data. If the time variable is a date or date time, it uses it directly. Otherwise, it tries to convert it into dates. If that fails, it uses a simple numeric index. The forecasting logic works like this. The values are converted into time series object. If there are too few points, only the historical series is shown. For naive, the last observed value is repeated into the future. For ETS, an exponential smoothing model is fitted and used to forecast for KNN or K nearest neighbors. It stands for K nearest neighbors model is used to predict the next high edge points based on the recent lags. Finally, the app plots the historical series as blue lines and the forecasted values as the dashed green line with points. The show subtitle shows which model and which variable are being used. Next, we have the page of insights and reports. On the Insight tab, the app automatically reads the structure of the dataset and lists total columns and values, how many numeric, categorical, and date time variable there are. If then creates bullet point describing the key numeric patterns for the first numeric variable, it reports the mean and standard deviation. If there is a second numerical variable, it creates the correlation between the first two numeric variables and reports that value. The last section describing forecasting behavior. It orders the date. It orders the data with time, creates a simple index and fits a linear model. It predicts a future value using this linear trend. It tells you whether the trend is upward or downward and shows both the last observed value and the future predicted value. Next, at the second last, we have the video and contact page. On the video tab, the app embeds a YouTube video in an iframe so users can watch a walkthrough inside the dashboard. As you are all are watching, a sidebox lists what a video covered, such as uploading data, navigating the pages, and interpreting the visualization. On the contact tab, the app shows a profile picture and a fields for name, email, and phone. It also has text areas where you can describe your education, skills, and experience. This turns the dashboard into a small, interactive academic profile and portfolio. At the very end of the script, the Shiny App UI, server call connects the user interface and the server logic and runs the full dashboard. Where you run this file, the app starts, and all these pages become interactive in your browser. Thank you.